Okay, this is part 2 of Unit 1B, and we're looking at propositions and truth values. And this next portion that we're looking at what are called logical connectors. And we have propositions that are often joined together with these logical connectors. And they're words such as and, or, and then also one of the big ones is the if-then statements. So first we're going to be looking at the and statement. And well, I guess, before I get ahead of myself, let's look at two propositions. And a lot of times, again, we'll call these P and Q. So the first proposition is the test was hard, and the second proposition is I got an A. If we join these together, we get a new proposition. And so we can have, the test was hard and I got an A. We can join them with an or statement. We get the proposition the test was hard or I got an A. And although these statements do seem very familiar with how we speak in everyday life, we still have to analyze them carefully for their truth value, their validity. So first we're going to look at this idea of and statements. Okay, an and statement is called a conjunction. And when we look at the rules of logic, conjunctions P and Q, that is only true. So P and Q is only true if P and Q are both true. So in an and statement, both propositions have to be true in order for the new proposition with and to be true. And when we look at this, we create a truth table. Now notice down here, this truth table, oops, I don't know why we did that. Oh, it's because I didn't get my pen. So we look at down here. Here's our truth table. So I'm kind of jumping over the top of a little bit of stuff there. But this is how you would create this truth table. So what I've highlighted there in red, I'm just going to be separated in some columns. And then you do it in rows. So we've got the proposition P, we've got the proposition Q, and then the conjunction P and Q. And again, P and Q is only true when both P and Q are true. So notice the first one says, so like this first row right here, T, T, and T. That means that P is true, Q is true, therefore P and Q is true. So P and Q is dependent upon the values of P and Q listed in the first column. So if I were to jump down and look at this one here, P is false, Q is true, okay, then P and Q is going to be false because one of them is not true, and then if they're false and false, obviously you get false. True and false will be false also. So the only time that an and statement is true is when both are true. So if we look at an example here, okay, so the following statements have the form of P and Q. We want to state P and Q and then give their truth values. Then determine whether the conjunction, which is the and statement, is true or false and explain why. So 12 plus 6 equals 18 is our proposition P. 3 times 5 equals 8 is our proposition Q. Each of these have a truth value. So 12 plus 6 equals 18 is a true statement or true proposition. 3 times 5 equals 8 is false. So when we look at, kind of the and, when we look at the and together here, that's going to be false because the first proposition is true, the second is false, therefore the conjunction, the and statement, is false. Okay, another one of these logical connectors is the or statement. Okay, and the or statement can be a little bit more complicated. Okay. So there are a couple different meanings. So if a health insurance policy says that it covers hospitalization in case of illness or surgery, it probably means it covers either illness or injury or both. So That's what we call an inclusive or statement when it goes either or both. I guess there's that word, inclusive. However, in contrast, when you look, if we go to a restaurant and you have a choice between soup or salad, you're probably not going to be able to choose both soup and salad unless you pay for both. But if it says on the menu you get your choice of soup or salad, okay, you're only going to get one or the other, but not both. And this is what's called an exclusive or, meaning you get one or the other. So depending on the context, that's how we can identify whether something is inclusive or exclusive. However, in logic, this is kind of a key thing here. We assume that or is inclusive unless we're told otherwise. So we do assume that it's either or both unless we are told otherwise. But let's just look at some examples of the differences between exclusive and inclusive here. So we want to state whether it is inclusive or exclusive in these three examples I've got here. So before the entree, you have your choice of soup or salad. Okay, and as we mentioned before, this is the exclusive because you get one or the other, but not both in soup or salad. Our next one, oil change is good for 5,000 miles or 3 months. Okay, this one is also exclusive. One of the reasons is because in very rare instances does that occur. And if you go to get your oil changed, very rarely, if you go at 3 months, are you exactly at 5,000 miles. So this is exclusive. Either you hit 5,000 miles or 3 months. And usually, if you go to get your oil changed, they'll tell you whichever one comes first. But this definitely is an exclusive proposition when we're looking at or. Okay, the last one, the insurance policy covers fire or theft. Okay, very safe to assume that this would be inclusive because I doubt an insurance policy is going to only cover fire or only cover theft. Usually your insurance policy is going to cover both of those. So that would be inclusive because it could be either or both. Okay. And let's see, just need to check my time here. We'll finish up or, and then we'll jump into the if-thens in the next video. So a compound statement with or is called a disjunction. Again, we always assume that the ors are inclusive. So for the disjunction, P or Q is true if either one or both of the propositions are true. Okay. And here's our truth table that we would have for this. So notice that there's a lot more in the end. We have a lot more trues occurring for P or Q than we did for P and Q. Because again, in a disjunction or with the or statements, only one or both have to be true in order for the disjunction to be a true statement. So the only time this is false is when P and Q are both false. Then one or the other, if they're both false, then the whole entirety, the whole disjunction is false. Okay, so if we look at an example, the following has the form of P or Q. So we want to determine which is P, which is Q, which are two propositions, and then determine whether the disjunction, the or statement, is true or false, and explain why. So we have 2 plus 2 equals 5, so there's 1, so we'll call that P, and 3 plus 3 is 7, we'll call that Q. Okay, now the truth value for 2 plus 2 equals 5 is false, and the truth value of 3 plus 3 is also false. And so when we look at our or statement here, and we want to determine whether this is true or false, we have false or false, and that implies false. So if we look at our truth table, okay, that's this scenario right here, false or false. So that gives us a false statement. Okay. So that's the or case. Again, inclusive is what we always assume unless we are told otherwise on those. So the last thing you're going to look at is if then, which is called conditional statements, and we will continue that in the next part of the video.